simple color wheels. How do we choose our colors then? What happens for a Newtonian color wheel is you can distribute the color on a wheel, and this is what you see in your computer programs, right? This is the version of it. So here we have yellow, green, cyan, blue, violet, magenta, and red, orange. Now, if we're dealing with paints, we would have yellow, magenta, and cyan as our primary colors. The primary color is a color that no other colors can be mixed together to make that color. But all other colors are made using those three primary colors. If we're using pigments, our primary colors are magenta, yellow, and cyan. If we're using our computer using light or on stage using gels, we have what we call blue, green, and red. I want you to notice that this blue is really blue-violet and this red is really a red-orange. When we're making our images in the computer, we have red, green, and blue. When we're producing them for figures in the journal, we have to convert them to cyan, magenta, and yellow, CMYK, the K being for black. Now if we stick with our colors from the computer for the primaries, red, green, and blue, and we add them together, we get white in the center. This one shows that if you use the primaries that are yellow, magenta, and cyan, and you mix them together correctly, you're going to get a dark gray when you mix them all three together. Note the relationship between the additive and subtractive systems, where you're taking the red, green, and blue and adding them together and get white. That's called the additive system. The one where you get gray is the subtractive system. But look at this. Yellow, right across on the color wheel is the blue-violet. So, yellow for the pigments as a primary color. A secondary color is a blue-violet, which is the primary color in the additive. Okay, so there's a relationship between all of those. Okay, so if you go green to magenta, magenta is the primary in the subtractive, and green is the primary in the additive, and they're directly across from each other on the color wheel. And what I'd like you to notice is that I selected those today for my colors. Okay, so I have pink on my cups and green in my dress. This is a harmonious color composition. To pick the colors across from each other on the color wheel, they're called complementaries. So not as in magenta is complementing green on how sexy he is, but it means it's a different complement. Now I also mentioned harmonious colors, okay? That's not an opinion, that's a term. So if you selected them slightly off and you added them together, say you picked green and something between these two and added them together, you wouldn't get this nice gray in the middle, you would get brown. Brown is the least harmonious color. So you want to avoid the brown. How do we avoid the brown? How do we pick perfect complements? This is what I'd like you to do. I want you to stare at this for 15 seconds and then we'll look at this little dot over here. Let's start here. Let's all count down. 15, 14, 13, 12, 11, 2, 1. Look at the other dot. It's very bright in here. Can you see anything?
Purpley bluish.
That's right. That's right. What you see over here is this patch here gets lighter, and right in the center here you see the purple glow. Your eye-brain system puts that together. So that's how you can pick a complementary color and make that harmonious color composition. I want to go back for a second and tell you that you can make a harmonious composition by also splitting your complements. So if I went from the yellow right across to the purple here, I could also make a harmonious composition with three colors by splitting the complement equally along the color wheel. So I could do yellow, magenta, and cyan. Or I could do yellow and colors that are in between right here. So you can use more than two colors to create your color composition. Tints, tones, and shades. So we all use these words interchangeably sometimes, but let's look at this and define them. Here we have a pure hue chosen, it's red. If I move it a bit towards white, we get what's called a tint. If I move it a bit towards gray, I get what we call a tone. And if I move it a bit towards black, we get a shade. Why is this interesting for astronomy? Because I want to see some images that look like this. You can pick any color you want, any bunch of colors you want, but add gray to them all so that you get a tone. And if you make them all of the same value, that is, they're all the same value of lightness or the same value of darkness. They all appear the same lightness or they all appear the same darkness. That's great. And then you pick another color and you add a bit of white to it to create a tint. And when you do that, it will glow like neon gas. So I would just love to see nebula done where you have this glow. Here's something that's handy to know. Go across the color wheel. In this case, we're going to go from the orangey red through to the cyan. Let me take the orangey red, add a bit of cyan to it, I get this kind of a color. And if I take the cyan and I add the orangey red, I get that kind of color. And if I do this right, and I have exact complements right in the middle, I'm going to get gray. Well, how can we use these compensating tones, these in-between tones right here? Remember I said that, well, we had this experience where we have the red ball coming forward and the blue going back. Now when we look here, we have the blue coming forward and the red compensating tone going back. So you can use red and blue together and have the same legend that you want for red shift and blue shift. If we were doing black and white images, for contrast, we would just have levels of gray, and white and black would be at the ends of that spectrum. When you're dealing with color, you have 7 color contrasts, and these were described by Johann Sitten. I'm describing them here based on Newton's color wheel. So the strongest color contrast is the juxtaposition between the primaries, and they're saturated. Then you can do a light-dark one, where you can use any color. So here we have green with blue, but one's light and one's dark. And then we can do a warm cool. Now this is different for artists. So warm is the yellow and cool is the blue, just like we saw in the Van Gogh landscape with snow.